In this video, we're going to use the results about friction that we discovered in the previous video to answer some mechanics questions. Now, the important thing, first of all, is to recall the key facts from the previous video. And what I would suggest you do at this stage is just pause the video and read through the summary sheet that we had in that last video. So just pause the video and read through this lot. Okay, I'm hoping that you've now read through that and we can start having a look at some examples. We've got a particle of mass 1.5 kilograms is pulled across a rough table by a horizontal string. If the coefficient of friction between the particle and the table is 0.35 and the acceleration of the particle is 2 meters per second squared, we've got to find the tension in the string. So let's complete the diagram. We've got the weight is 1.5 g. We've got the tension in the string, and the string is horizontal, so it's parallel to the table. We've got the normal reaction, and we've got the frictional force. And we're told that we've got an acceleration of 2 meters per second squared. So we're going to use Newton's second law, and we're going to start off by applying Newton's second law parallel to the table. We're going to apply Newton's second law to the right. And Newton's second law says the resultant force to the right, which is T minus F, will equal the mass times the acceleration to the right, which is 1.5 times by 2. So we've got T minus F equals 3. But in order to find the tension, we need to know what the frictional force is. Since the particle is moving, the frictional force will equal its maximum value, which is mu times r, and we can find r by resolving vertically. So applying Newton's second law vertically now, we're going to have the resultant force vertically is the mass times the acceleration in the vertical direction. The resultant force vertically is r minus 1.5 g. The acceleration vertically is 0, so we've got r minus 1.5 g is 1.5 times by 0, in other words 0. So that tells me that r is 1.5 times g, or 14.7 newtons, in which case the frictional force F is mu times r, so F is going to be 0.35 times by 14.7, which is 5.145 newtons. So we've got T minus 5.145 must equal 3. In other words, the tension is 8.145 newtons. In our second question, we have a particle of mass 4 kilograms is on a rough table when a force of magnitude p newtons and acting at 30 degrees above the horizontal is applied to the particle. We've got to find an expression, first of all, in terms of p for the normal reaction between the particle and the table, and we've got to describe what will happen if p is bigger than 78.4. So again, we need to put some forces on. We've got the weight of 4g, we've got the pulling force of p newtons, making an angle of 30 degrees above the horizontal. We've got the normal reaction, and we've got the frictional force, and we've got the motion to the right. If the particle remains on the table, then the resultant force vertically must be 0 because there's no acceleration vertically. In other words, applying Newton's second law vertically, we must have r plus p sine 30 minus 4g equals 0, which tells me that r is equal to 4g minus p sine 30. In other words, r is 39.2 minus 0.5p. If P is bigger than 78.4, then we're going to have R is a negative value, which is impossible. When P equals 78.4, R is equal to 0, and the particle is on the point of leaving the table. So a value of P which is bigger than 78.4 is basically going to pull the particle off the table. So, for part B now, we're given that the coefficient of friction between the particle and the table is 0.6. We've got to find the acceleration of the system if P is 32 newtons. So if P equals 32 newtons, then our previous equation, R equals 39.2 minus 0.5P, gives me R equals 23.2. So the frictional force, because we've got some movement, is going to equal its maximum possible value, which is mu times R. So that is 0.6 times by 23.2, which is 13.92. So we've now got our force diagram revised, and we can apply Newton's second law horizontally now to find out the value of the acceleration. The component of P horizontally is going to be 32 cos 30. So the total component horizontally, or the total component of the resultant horizontally, is going to be 32 cos 30 minus 13.92. And Newton's second law tells me that that must equal 4 times A. So we've got 32 cos 30 minus 13.92 equals 4A, which means that A must be 3.45 meters per second squared. If the value of P is very small, then the friction will be sufficient to stop the motion. The maximum value of P we can have will be when the equilibrium is limiting. And limiting equilibrium means that F is equal to F max. In other words, F is equal to 0.6 R. So we've got the frictional force is going to be 0.6 times by 39.2 minus 0.5 P. So if we now just simplify our expression there, we've got the frictional force is 23.52 take away 0.3P, and if we apply Newton's second law to the right, because the particle is in equilibrium, there is no acceleration. So we've got the component of P horizontally, which is P cos 30, minus the frictional force, must equal 0, which gives me P cos 30 minus 23.52 minus 0.3P must equal 0. In other words, collecting together the P terms, we've got P times cos 30 plus 0.3P minus 23.52 equals 0, or P times by cos 30 plus 0.3, take away 23.52 equals 0, which gives me P equals 23.52 divided by cos 30 plus 0.3, in other words 20.17 newtons. So a force of 20.17 newtons is the biggest force that we can have for which the system will be in equilibrium. For our third example, we've got a particle of mass 20 kilograms is pulled up a slope inclined at 16 degrees to the horizontal by a force P parallel to the slope. If the coefficient of friction between the particle and the slope is 0.2 and the particle is accelerating up the plane at 1.8 meters per second squared, we've got to find the value of P. So our first job, as usual, is to draw a diagram. So here's our finished diagram with the 4 forces on and an acceleration of 1.8 meters per second squared. If we apply Newton's second law up the slope, then we have got, first of all, P minus the frictional force minus the component of the weight into the plane, down the plane. And the component of the weight down the plane is going to be 20g sine 16. So the resultant force is P minus F minus 20g sine 16, and that's got to equal the mass, 20, times by the acceleration, 1.8. Now, to make any progress, we need to know what the frictional force is. Since the body is moving, we know the frictional force takes the same value as F max, so we can say that F is equal to mu times R, which in this case is 0.2 times R. So if we can find R, then we can then find F, and having found F, we can find the value of P. So resolving perpendicular to the plane, we've got R minus the component of the weight into the plane, and the component of the weight into the plane is 20g cos 16. So the resultant force is R minus 20g cos 16 into the perpendicular to the plane, and that must equal a mass times by the acceleration perpendicular to the plane, and the acceleration perpendicular to the plane is 0. So that gives me R must be 20g cos 16, or 188.4 newtons. F therefore must be equal to mu times R, which is 0.2 times R, which is 37.7 newtons. So our previous equation becomes P minus 37.7 minus 20g sine 16, which is 54, must equal 36. In other words, P must equal 127.7 newtons. Now at this stage, it's time to pause the video again, because there are 3 questions for you to have a go at. They're reasonably short questions to make sure you've got the idea of using the friction model for solving problems. And as usual, take your solutions along to your next lesson, and you'll be able to discuss them with your teacher.